Hello all, welcome back to the third video of 3 for particle motion. I'm going to go through a couple of more questions, probably in a very fast rate, just to kind of let you guys get exposed to some of the other questions that I haven't done yet. We're going to start here at question number 2. It says a projectile starts at time equals 0 and moves along the x-axis, so that its position is given by this function right here. During what time intervals is the particle moving to the left? So what I always tell students to do with these kind of questions is thinking, okay, well, we're talking about particle moving to the left. Well, that's a velocity, right? Velocity positive, it's to the right. Negative, it's to the left. So I want to know where my velocity is less than 0. That's really all I got to find out. So on this particular thing, function. So the first thing I got to do is figure out, well, what is the velocity? And that's going to be 3t squared minus 12t plus 9. And then I've got to set this equal to 0. I gotta set this equal to 0, so I'm going to pull out a 3 for a second, just so we can do this. And then I get that t, when I factor this is t, this is t, this is 3, this is 1, and it's minus and minus. So I know that at time equals 1, and at time equals 3, I know that my velocity is 0. So that means that if this question is said, at what time is the particle at rest, there's your answer. That's all you have to do. Find your velocity, set it equals 0, you're good to go. But we want to figure out where it's moving to the left. So what I always have students do is I have them do a number line. And I always want them to label what we're actually plugging back into here, too. So in this particular example, we're asking where the particle is moving to the left. Well, then I'm plugging back into my velocity. I also wanted to say really quickly, if one of these times had been negative, you get rid of it. Time is always positive. It's always going to be given to you here. So any negative value, you would obviously get rid of it. So I also am going to say that because of that, I'm going to go ahead and cap my left side here with 0. I don't want to, because I don't want students to think that it's negative infinity to 1. It's got to be starting here at 0. So that's the first thing I say. So go ahead and I plug in my values to in here. I can plug in 0. I can plug in 0 to my velocity function. If I plug in 0 to this, I get a negative 1. I plug in 0 here, I get a negative 3. And so my sign when I plug in 0 is going to be positive. So from 0 to 1, this will be positive. I can go ahead and plug in 2. If I plug in 2, I get positive here. I get a negative here, so it's going to be negative, and then I'm going to get a positive. So all I'm looking for is where it's less than 0. So it's less than 0 right here. So this answer is going to be C. Okay, so less than 3 minutes, I got that answer done. All right, so let's keep on moving here. So question number 3. This question students really get confused about. So number 3, a particle's motion is described by, again, the position function. Again, t is greater than or equal to 0, where t is in seconds and distance is in meters. Find the average velocity. The average velocity. So we've actually had this conversation already before. Average velocity is going to be, and again, I'm going to go ahead and just make this an S, just because of position function. So average velocity is going to be just the position function, and it's just the slope of the position function. So we do not need to find a derivative here. We do not need to find a derivative here, and that's a common mistake made. Students see velocity, and they think we have to find the derivative. We do not. But what is the A and the B? And that's the other really confusing part of this question. It says during the third second. So 0 to 1, that's the first second. 1 to 2 is the second second. 2 to 3 is the third second. So I want it on the interval from 2 to 3. Right? A lot of students think during the third second, not over the course of 3 seconds, but during the third second. So I want 2 to 3. So I got to find s of 3 minus s of 2 all over 3 minus 2. So I have to plug 3 into here. I have to plug 2 into here. And again, to save some time, I know that this is going to be 63. This is going to be 12 over 1. And so it's going to give me 51 meters per second. So this answer is going to be D. Okay, so let's look at question number 4. Question number 4 has 3 parts to it, and I really just care about part C, but you need to answer A and B to actually solve C, so we're going to do this very quickly. It says the position of the particle is given by this cubic function. When does V equal 0? So when is velocity equal to 0? So we're going to find the velocity very quickly using the power rule. And then we're going to see, okay, well, we're going to set that equal to 0. We're going to factor out a 3 again, like we just did. And we're going to factor. So we get t, we get 4, we get 1, we get negative. We get a negative here and a positive here, so I get time equals 4, and time equals -1. So I know clearly that's not right. So at time equals 4, my velocity is 0. And we could have automatically, before we started the problem, could have get rid of those two. So that's the answer to that question. The next says, when is the acceleration equal to 0? Little quick note here, we can actually find the derivative of this if we want to. They're going to be the same thing when you solve for it, so I'll show you guys both ways. This is the velocity that's right here. So if I found the acceleration based on this, then it would be 6t minus 9. If I found the derivative of this is the other acceleration, I would get 2t minus 3. Because I'm setting equals 0, either one works. If you're not setting equals 0, you always want to go back to the original. But when I set these both equal to 0 and I simplify, I get the t is equal to 3/2 over here, and I also get the t is equal to 3/2 over here. So a quick strategy that if you're setting equal to 0, then you can just go ahead and do the simplified version. If that confuses you by any means, then just go ahead and just always take the derivative of the original. All right, so this is what I care the most about. When does the speed of the particle slow down? When does the speed of the particle slow down? So I have 2 places on my number line. I've got at time equals 3/2, I have my acceleration is at 0, and then at time equals 4, my velocity is equal to 0. So what I want to do is I want at the top of my number line velocity, the bottom of my number line I want to do acceleration. And so if I plug in 0 to the velocity, I'm going to get a negative value, right? I'm going to get a negative value here. And if that confuses you, you can literally plug it into here. I get 0, 0, and then a negative. So I'm going to have a negative value in right here. If I plug in something like 3, right, something between these two numbers here, 3, I get a negative value here, and I get a positive value here. So I'm also negative. And that should make sense, ladies and gentlemen, because I'm only 0 at -1 and at 4. So these sides should be the same value, by the way. And then if I plug in something to the right of 4, I'd do something like 5. So I'm just finding the values of my velocity function at given values. And then if I'm down here for the acceleration, I'm at this little guy right here. If I plug in 0, or if I plug in 0 to this, I'm going to get a negative value. If I plug in something, let's say 2, I get 12 minus 9 is positive. If I plug in something like 5, I'm also going to get a positive. So the question is, when is the speed of the particle slowing down? Well, my answer to this problem is going to be, when they have different signs. So this is when velocity and acceleration have different signs. And so I have to incorporate, though, when both of them are at 0. So their different signs is right here on the interval from 3/2 to 4. 3/2 to 4. And so this is the answer to this problem. If I asked you guys from when it was speeding up, then it would be from 0 to 3/2, and then from 4 to positive infinity. Okay? So, or they would give you an interval, say on the interval from like 0 to 7. So you just like 4 to 7. So that is the third question that we've done. Pretty quick here. Okay, so I'm not going to do this next question right here, but I just want to just really quickly talk about it. There's 2 more I want to go over, and then 1 more I want to explain. This says a moving particle travels along the x-axis of the positions given by this function right here on the interval from 0 to 7. How many times does the particle change direction? So all you have to do here is find the velocity of the function, set it equal to 0, and then find the times where the velocity is 0. And then you have to just do a number line, and plug in your velocity. So let's say it's plus, minus, plus. Then you know your answers are going to be the actual values of time where the velocity equals 0, because this would be forward, this would be backwards, and this would be forward. So you're just really looking to see when does this velocity change signs. All right, so that's all that you have to do for that one. And I have my answer key online for you guys to look at for this work. All right, so it's velocity changes signs. So we're moving on through that question. I'm also not going to talk about this one. We just talked about in what direction left or right is the particle moving at time equals 5. So again, you would plug in, just really quickly, notice that velocity in this problem is already given to you. So when you're doing A, you do not have to find the derivative of this. And the other thing I just want to say to you guys really quickly, if I were to ask you guys to find the acceleration, wouldn't it be much nicer? Wouldn't it be much nicer to do the acceleration like this? Remember, we talked about splitting this up. So find the acceleration. Is the velocity increasing at time equals 5? And then, is it the particle speeding up, slowing down at time equals 5? So one thing I do want to say about this question is right here, students always get this wrong. Remember that there's a difference between positive and increasing. So let me actually write the answers down to this. Hold on for 1 second. So I went ahead and wrote the answers up for this because I do need to talk about this for a little bit of time. So I saved a little bit of time with this. It says, in what direction left or right is the particle moving at time equals 0.5? So I literally plugged in 1/2 into this equation and I got -5. All right. Then it says, find the acceleration of the particles. So again, I just really quickly did the derivative of this over here, and then I plugged in 0.5 here and I get 14. The point I want to make with this question is the velocity increasing at time equals 0.5? I want you guys to make sure that you understand the difference between positive and increasing. All right, there's two different things with this. Is the velocity increasing or is it positive? So let me give you guys a visual of what this looks like. How can something be positive? So if I give you guys, this is my velocity graph, and I give you something like this, okay? This piece right here, this little piece right here, this is where velocity is negative because it's underneath the x-axis, but it's also increasing, right? It's increasing. So be careful with that. So it says, is the velocity increasing at time equals 1/2? And the answer is yes, because the acceleration is positive, right? Remember that the acceleration is essentially the slope of your velocity function. So students look at A and say, this is a -5. The value of the velocity is -5. So that would be, let's say here, that would be -5. So that's the actual value of it. But what's going on around 0.5 is positive slope, so it's increasing. So I wanted just to really quickly talk about that. I'm so sorry that I'm all over the place in this video. I just wanted to highlight so much stuff in the video and not, waste too much time. So think about that. And like I said, if you guys have any questions about this in class, please let me know and I can go over it a little bit slower, hopefully. Speeding up, slowing down, we've talked about that so many times. So this is a really good question, number 7. So I'm going to go over this one. It says a table of values for the velocity of a motorcycle at 6-second intervals is given below. It says, how, during which intervals of time is the acceleration of the motorcycle positive? So remember, we're looking at velocity here. Now, one of the things you can do that would be really, really, really tedious is you could literally plot all these points and just see, well, when the acceleration is positive, that means that the velocity is increasing. So that kind of goes back to the question I was just talking about, that the velocity is increasing. Well, from 0 to 6, it's going from 0 to 15, so it's increasing. So 0 to 6. 6 to 12, it's increasing, positive, increasing, 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 and then all of a sudden here at this interval it does not. So from 0 to 42, and again, if you guys really wanted to, you could plot these points and you would see as you're going from 0 to 42 that your y value is increasing, therefore your slope is positive, therefore your acceleration is positive. And then it goes to 75, 72, and then from 72 back to 81, we're also increasing. So it's 54 to 60. So my velocity is increasing, and again, where velocity is increasing, that means my acceleration is positive, because when I'm increasing, that means the slope is always going to be positive. So that's how you answer part A. Part B, you have not seen this yet. It says, what's the average acceleration? The average acceleration. Well, you learned that average velocity is the position function. So the average acceleration is going to be v of b minus v of a over b minus a. Because again, the slope of velocity gives you the acceleration. So if I look at this, I want v of 42 minus v of 12 all over 42 minus 12. So in this particular example, you guys have to understand that you're given velocities, so that you have to look at the values. So 42, you get 80. V of 12, you get 22 all over 12 minus, or sorry, 42 minus 12, which is 30. And then you can simplify this more. And by the way, this is an FRQ question, so I would leave it right here. I would leave it right here because it doesn't say it's a calculator question. I would hate for you guys to get the point wrong because you subtracted incorrectly. So I would highly encourage you guys on FRQs to leave it just like this. And then obviously it would be in feet per second squared. So average acceleration, you're now learning that that is just going to be your velocity slope, just like average velocity, which we've talked about in this video as well, would just be position. So you guys will see we're adding up a lot of stuff right here, right? There's a lot of stuff going on. And then the last example here, what is the approximate acceleration? So now we're looking at the actual approximate acceleration at time equals 30. Okay, so we want the approximate, and this question comes up a lot in calculus. So it says, what's the approximate acceleration of the motorcycle in feet per second squared at time equals 30? And notice that this is, again, a chart for velocity, So what you will always do is you will go to the one that's the closest to the bottom of it and the one that's closest to the top of it. So the approximate acceleration for 30 is going to be the velocity from the right minus the velocity from the left. And why does this make sense? Because if you were to plot these points, one here and one here, and you were to do something like this, the slope of the tangent line, and let's say I'm looking at, this is 30, right? So this is 24 and this is 36. The slope of the tangent line between these 2 points here is going to be very similar, or pretty close to 30. It's an approximation. So in layman's terms, if I asked you guys to find it at 48, you would do 54 and 42. That's to you. So you would find the 71 minus 60, 71 minus 60, all over 36 minus 24. And again, I would leave my answer like that. So yeah, that's how you do that problem. And again, I am so sorry that this is going by so fast, but I'm trying to hit a little summary of every question as we work these problems. Okay, I got one more to do and one more I want to show you guys just how to do it. Question number 8, I just want to be very, very, very careful with this one. When you're finding the acceleration of this position function, remember that this position function is just 3t minus 2 to the 1/2 power. Remember that when you do this velocity, you have to worry about the chain rule. So it's 1/2, 3t minus 2 to the negative 1/2, and then we're going to multiply by 3. So just be really careful about that. And so what I also want to tell you guys is that when you do the acceleration of this, I would just leave this exponent up. So I would rewrite this as 3/2. I would do 3t minus 2 to the negative 1/2. Because when I find the acceleration, I'm just going to move this down and multiply that together, and I'm going to get negative 3/4, 3t minus 2 to 1 less power. And then I'm going to multiply again by 3 again. You have to remember that when you're doing this, that you have to multiply 3 both times, and students forget that. And then all you have to do here is plug in 2, and then you get your answer, which I think is this answer right here, B. Okay, so we have one more example left to go, and I noticed that I'm at around 20 minutes. I probably should have spent a lot more time on these problems, but like I said, my goal is just to kind of highlight every question for you. And for anyone that's watching this video, I really do apologize for how much scatterbrained I've been, but I'm trying to go as fast as I can just to summarize and give you guys an overview of how to do these questions. So for question number 9, this is the last one. It says, find the graph has a velocity. So it tells us the velocity, which again is really important. So this is the velocity function. It says, find all times on the open interval in which the particle changes direction. Justify your answer. So this is just another graph analysis problem. So right here at time equals 2, we know that the particle changes direction because velocity is negative here and it's positive everywhere else, right? Because literally it's above the x-axis, below the x-axis. And so you would say time equals 2, and you would say that my velocity changes signs at x equals 2, or at t equals 2. All right. You never want to ever justify something by saying something's below the x-axis, above the x-axis. And we talked about lesson number 9, which I will go through much slower. You guys will see that case, how to justify stuff practically. For B, it's asking us to talk about for what value of t is the velocity increasing. So we've had this conversation before. Velocity increasing is not the same thing as velocity being positive. So when you see velocity increasing, you need to think about when is my acceleration greater than 0. So these are the same thing. Velocity is increasing where my acceleration is greater than 0. So you're looking at slope. This is the justification, by the way. You justify your answer. That's all you have to write. So when you see velocity increasing, you write the acceleration is greater than 0. Never, ever use slope. Do not say the slope of velocity is positive. That is not a legit calculus response. You need to say that the acceleration is greater than 0 because the slope of velocity is acceleration. So you guys can see that starting at 1 all the way up to 4, right? 1 up to 4, I have a positive acceleration. And then I have it again from 6 to 7. So these are your intervals, and this is your reason, your justification. Okay, so that is the first 2 parts. All right, part C. At what time intervals does the particle travel to the left? Justify your answer. So remember, for this one, justify to left. This is where your velocity is less than 0. Right? So this is your value. Your value is less than 0. And so your value is less than 0 from 0 to 2. So it's 0 to 2. And again, your justification is not that it's below the x-axis. And always stay away from the words did and stuff like that. And here's your justification right there. So sometimes when I tell students to actually think about what you're looking for is the justification. You would say 0 to 2 because my velocity is less than 0. And that's it. That's all you have to do. Again, stay away from it's underneath the x-axis. We don't like to say slope. We don't like to say axis. We definitely don't like to say the word it, right? What is it? Is the particle speeding up or slowing down at 1.5 seconds? So at 1.5 seconds. So at 1.5 seconds, you guys can see that we're right here, right? And so I'm going to put the answer here, but this is for part D. So if you look at this, our velocity is less than 0. Because again, it's underneath the x-axis, but our acceleration is greater than 0, because again, our slope is positive here. So our velocity is less than 0, because it's underneath the x-axis, acceleration is greater than 0, because the slope is positive. So since these have different signs, then I can say that they're slowing down. I am slowing down. Okay, so then once I get above 2, so something like 2.3, then I'm now speeding up. Right? I'm speeding up. I'm speeding up. I'm speeding up. Slowing down. Slowing down. Slowing down. Slowing down. Speeding up. Speeding up. Speeding up. Does that make sense? So here, I'd also be speeding up. All right, guys, that finishes up lesson number 8 for particle motion. Next time, we're going to look at lesson 9, which is derivative graphs, where we will go and analyze them a lot more than we did here. So I will see you guys in the next video.